This video is going to be talking a little bit more about roots. If you remember way back a long time ago, we looked at square roots and simplifying square roots. Today we're going to look at different roots, cube roots, fourth roots, and so on. So it shouldn't really be super new, but it's just taking a little bit, taking what we know already with square roots and taking it a step deeper. So we have what we're going to call them nth roots. So it kind of looks like a square root symbol, but depending on what power, so what root I want to take, I'm going to put a little number out in front here. So if I want to take a cube root, I'm going to put a 3 up there. So maybe I want to take the cube root of 8. So we know that the square root of 9 means what times itself gives us 9, and the answer to that is 3. So the question here, if I'm taking the third root of a number, is what number times itself 3 times gives me 8? So 2 times 2 times 2 gives me 8, so the cube root of 8 is 2. So whatever my root is, I can also write it as an exponent, okay? And we're going to write it as the 1 over n power. So if I wanted to do a square root, like the square root of 9, I can write that as 9 to the 1/2 power. Likewise, the cube root of 8 is 2 to the 1/3 power. Okay, so we also know that roots and their powers, raising them to the power cancels out. So if I want to undo a square root, I'm going to square both sides. So we know the square root of a squared is equal to a. And if I think about it in terms of these exponential powers, if I have a to the 1/2 and I raise it to this second power, then I multiply power to a power, we multiply them, so I get 1/2 times 2 is 1, and that's why they cancel each other out. Now, the thing that we have to remember with all these roots is whether or not I can have a negative number underneath the root. Okay, so square roots, we know that if I try to take the square root of -4, that is an imaginary number, and we call that 2i. So, the same is going to apply for any even root. If I take the square root to solve, then I must include a plus or minus. So even roots, if I solve for x, I need a plus or minus. And it also means that I cannot have a negative under the root. So fourth root, sixth root, eighth root, and so on, if there's a negative under the root, we cannot have that. It would be imaginary. If I have an odd integer, then I can have a negative under there. And the reason for that is if I take the cube root of, say, -8, I know that that is equal to -2 times -2 times -2, which stays -8. So the cube root of -8 is -2. I cannot do that with an even power. It always has to be positive under there because the even will cancel out all the negatives. Okay, so let's look at a couple. I'm just going to erase here so that we can see what's going on here. So we're going to find the indicated nth root of some number. Okay, so this is saying I want to take the cube root of -216. That means what times itself 3 times gives me -216. That's -6. Now we're going to actually make a chart with some of the common powers because I know you probably might not necessarily remember or know that -6 times -6 times -6 is -216. Okay, let's do 2 more. All right, so this one is the fourth root of 81. That means what times itself 4 times gives me 81. And that's 3. Last but not least, I've got the fourth root of 625. So what times itself 4 times gives me 625? That's 5. All right, so let's move on to looking at what if I have not just 1 over some nth power. So what if, instead of just 1 over n in the power, what if I have a different number, like 2/3 or 4/3 or 5/2, and so on and so forth? So for instance, what if I had 64 to the 2/3 power? What I can think of that is 64 to the 1/3 raised to the second power. So basically the bottom line is I look at the fraction itself, and I know whatever the number is in the denominator is my root, and whatever the number is in the numerator of the fraction is then what I raise that particular answer to after I take the nth root. If the exponent is negative, you have to remember that means not that the number, the answer is negative, but that we take the reciprocal and we move it to the denominator. So for instance, if I want to evaluate 27 to the 4/3 power, I see that the 3 is in the denominator, so that means that my root is the cube root, and I'm going to put the 27 underneath there, so that means take the cube root of 27 and then raise it to the 4th power. So what number times itself 3 times gives me 27? That's 3, and then I raise it to the 4th power, which gives me 81. Okay, so if I do 32 to the negative 3/5 power, that means I'm going to take the 5th root of 32, and I know it's going to be in the denominator because it's a negative fraction. So I'm going to take 1 over the 5th root of 32 to the 3rd power. So that means 1 over 5th root of 32 is 2, to the 3rd power is 1 over 8. Let me do one more here. All right, so let's do, and we've got 3 halves. 36 to the 3 halves power means that the 2 in the bottom means square root. And I'm going to take the square root of 36. It's a positive, so it just stays where it is. Raise that to the 3rd power, so I've got square root of 36 is 6. To the 3rd power is 216. You can do these on your calculator. Okay, now if it's not a perfect root, it'll come out and just simplify the root for you. If you want the decimal answer, you're going to have to hit Control-Enter. So lastly, let's look at solving equations using these roots. Okay, so for instance, if I want to solve 2x cubed equals 432, before, if I had 2x squared equals, say, I don't know, 81. Okay, if I had divided by 2, I would have to get the square root by itself, or the x squared by itself first, divide by 2, so that would give me 81 over 2, and then I'd have to take the square root of both sides in order to undo the squared. I'm not going to go through all of that because that's new, but we're going to use the same idea for all of these. The thing I have to remember, though, is that now that I'm solving for x, do I need a plus or minus in front? With a square root, yes, I did. With a cube root, I do not, okay, because I can have, if I plug in a positive, I get out a positive. If I plug in a negative, I get out a negative. So first thing I'm going to do is divide by 2 on both sides, so that I have 432 divided by 2, which is 216. So I've got x cubed now equals 216. So in order to undo this cube, I'm going to do that particular root. So I'm just going to, it's getting a little hard to see here. So I'm going to take the cube root of 216, and I'm going to take the cube root on both sides. So now I've got x equals 6. I don't need plus or minus because it's an odd root. Okay, for part B, in order to get x by itself, if I undo my order of operations, I need to get rid of the exponent first. So I'm going to take the 4th root of both sides. So undo the 4th power by the 4th root. Because this is even, I need a plus or minus. So now I've got x minus 4 is equal to plus or minus, and the 4th root of 625 is 5. So just like when we were doing square roots, I'm going to add the 4 over, so that I get x equals 4 plus or minus 5, and then I'm actually going to evaluate that. So I've got 4 plus 5 is 9, and 4 minus 5 is negative 1. Both of these plugged back into the original equation would make this a true statement. All right, last but not least, example C. I'm going to, it's very similar to B, except I'm going to take the cube root, and since it's an odd root, I do not need a plus or minus. So I'm going to have x plus 2 is equal to the cube root of 21, which 21 is not a perfect cube, so I'm just going to leave it like that. And I'm going to subtract the 2 over. So I get x is equal to negative 2 plus the cube root of 21, whatever that is. Okay, so again, even roots, if you have to take an even root on both sides to solve for x, you put a plus or minus in front of it, just like we did in example, not example C, example B. In example C, we didn't need that plus or minus because it was an odd root.